అని సపరేట్ గా టాపిక్ అని మీరు టాపిక్ రాసుకొని అప్పుడు స్టార్ట్ చేసుకోవచ్చు. అది కాన్సెప్ట్ అంతే సపరేట్ గా స్టార్ట్.
Very good morning. In the last session, we finished the basics of the control system, open loop control system and closed loop control system, and its transfer function and its mathematical equivalent model. And based on that basics of the open loop control system and closed loop control system, then we will find two important parameters. From the open loop transfer function, we will find a type. From the closed loop control system, we will find order. So on the previous session also we solved a few problems, how to find type and order, and what is the question, and which we are already solved. Now from the continuation of that, then we will solve a simple question on that particular topic, then we will move for further analysis of our subject. Therefore, then the previous session you solve one question, then the same question then you solve. Now this is your workbook, question number 2. Question number 2. Question number 2. What is question number 2? By considering the closed loop control system transfer function, by considering the closed loop control system transfer function, C of S by R of S, which is equal to 2S plus 1 by S plus 1 whole square, and what he is asking is find order and type. This is the question. The same question actually which we have solved in the previous session, that is question number 1. Now this is question number 2. There we discussed everything, how to solve and how to convert it from one transfer function to another function, and we just see the one shortcut method for that also. Now use that shortcut method and get the answer directly. Now this is the closed loop control system transfer function. Once there is a closed loop control system transfer function, then you can directly find order, because this is the closed loop control system transfer function and these are the closed loop poles. Now where is the closed loop poles? How many closed loop poles? Now S plus 1 equal 0, S equal to minus 1, S equal to minus 1. How many poles? 2 poles. Therefore 2 closed loop poles, therefore order which is equal to 2. 2 closed loop poles, therefore order equal to 2. Now this is the closed loop control system, we can find directly order. But what is the question is asking? Order and type. Then the previous session also I am discussing, then while looking the type, then you don't see the number of poles at origin. Then most of you are thinking that the number of poles at origin is 0, therefore you think that the type is 0. That is wrong, because this is the closed loop control system where we can find only order. Closed loop poles will give only order, but the type is the parameter which we can get only from the open loop transfer function. Therefore, for finding the type, you go to the open loop transfer function. Don't see the number of poles at origin in the closed loop control system, will give the wrong answer. Therefore, this is the closed loop control system. From here you can find the order. For finding the type, you go to the open loop control system. And the last session also which we are identified how to convert a closed loop control system to open loop control system. This is the closed loop control system. From the closed loop control system to open loop control system, I am giving one shortcut method also. Now what is that shortcut method? Now this is the open loop control system transfer function. Directly the open loop control system transfer function, which is a forward path gain, directly you can get the numerator of closed loop control system, and the numerator of open loop control system is same as the numerator of closed loop control system, 2S plus 1, and the denominator of open loop control system is same as the denominator of closed loop control system, minus numerator of open loop control system, minus numerator of open loop control system. Therefore, once again just see here, the open loop control system I want to identify from the closed loop control system, and in a shortcut method directly the answer is open loop control system numerator is same as the numerator of closed loop control system, and open loop control system denominator is same as the denominator of closed loop control system minus numerator of closed loop control system. Is directly gives the open loop control system transfer function, which is nothing but 2s plus 1 by, then if you simplify, s square plus 1 minus 1 cancel, 2s minus 2s cancel, therefore this is 2s plus 1 by s square. Therefore, there are two open loop poles available at origin. Therefore, there are two open loop poles. Therefore, type is 2. So, the same question which we have solved in the previous session. Now, that is question number 1, same manner, and this is question number 2 in our handbook, and how to find the type and order. Use this shortcut method not only for finding type and order, anywhere you converting from one transfer function to another transfer function, now you take this particular shortcut method and you can easily get the answer. Okay, and here you just take one note also, because this you remember. Okay, don't blindly don't solve from one question to another question. Now, this shortcut method is valid only for unity feedback control systems. Okay, this shortcut method, now how you are finding from open loop to closed loop to open loop. In the last session also we just see the shortcut method, the same shortcut method used from one conversion to another conversion, but the thing you remember, while converting from open loop to closed loop or closed loop to open loop, then that is valid only for unity feedback system. Generally we are taking a unity feedback closed loop control system, then this is possible. For unity feedback system, then you use this approach. And one more thing also, now why the order you are finding from the closed loop control system? Why you are finding only type for the open loop control system? Then there may be a question in your mind, sir, why we want to choose only type from the open loop transfer function? Why we want to choose only order from the closed loop control system? Why we are not finding type from the closed loop control system? Why we are not finding order from the open loop control system? Now for that also, now there is a reason why the type is related to open loop control system, why order is related to closed loop control system, that you can understand very soon. Okay, that particular point also you keep in your mind, then that particular clarification which will be coming very soon in the next session. Okay, then you just take this particular question. Okay, so like that the concept which is how to find the type and order. Okay, and how to converting open loop to closed loop and closed loop to open loop also you just observe. Okay. Then you know how to find the type and order while the transfer function is given, and you know the type definition, order definition, and poles, zeros definitions, open loop control system transfer function, closed loop control system transfer function, and behavior, everything is also known to you. Therefore, now we will see in the concept of basics of control system. Then one more thing also we can easily identify. Now, how to identify the behavior of the control system. Then how to judge a control system is good or not. Then in the previous sessions also we discussed the control system complete behavior. A control system complete analysis is depends upon the control system parameters. Now the control system parameters are nothing but gain and time constant. Gain and time constant. These are the control system parameters. Control system parameters. The control system parameters, which is nothing but, now this is gain, control system gain, and this is control system time constant. Control system gain and control system time constant. Now what we are doing is, now these are the control system parameters, which is nothing but the control system gain and control system time constant. Then we are now try to find that how to find the control system parameters. Now one of the control system parameter is gain and another control system parameter is control system time constant. Now what I am saying is, now before we find the control system parameters, which is nothing but gain and time constant, now we have some basics of open loop control system, closed loop control system, and its behavior and its response, and what are the basic features of the open loop control system and closed loop control system, and what are the parameters which is coming from the open loop control system, closed loop control system, which we already discussed. Therefore, now what we are doing is, next concept what we are doing here is, then you just see here, these are the control system parameters, then which is gain and time constant. Now where it is useful? That is useful when you want to change the system behavior, when we want to see the system response, when we want to change the system analysis, then definitely the system parameters comes into the picture. Therefore, now what I want to do it is, then I am just ask one small question to you. If you want to purchase a mobile, then you go to the shop, then just look the mobile. The mobile is looking good. Can you purchase it? No. That is not the criteria to purchase a mobile. Then what you are doing for purchasing a mobile, tell me? While purchasing a mobile, then you go to the shop, then you see its features, you see its applications, then you see its characteristics, then you compare all these parameters, then you see the complete behavior of that particular mobile and complete characteristics of that particular mobile, then you go for you want to purchase it or not. In the same manner here also, then the concept what I am saying is, now I want to choose a good closed loop control system. A closed loop control system. If the closed loop control system is good, if you want to take it. If the closed loop control system is not good, we never take it. Right? So now my question is, for purchasing a good closed loop control system, for designing a good closed loop control system, or for taking a good closed loop control system, then how you can decide it, you tell me. How you can decide it, sir, this is a good closed loop control system, that's what I want to take it. So this is not a good closed loop control system, I am not taking. This is a good closed loop control system, I am taking like this. And this is not a good closed loop control system, then I don't want to take this one. Then how you can choose that? How you can choose that this is a good one and this is not a good one? Then how you can decide it that? That you can decide it now based on this is the closed loop control system, good or not, is decided based on response. Closed loop control system response. If it is a good closed loop control system, we can purchase it. If it is not a good closed loop control system, we cannot purchase it. That is based on its response. And this response you can get only when we are applying some. Then how can you get the response? Response means what I'm saying. The response means output. Then how you can decide the response? How you can get the response? Any control system response you are getting after applying some input. You want to give some input. So now this is the concept. What is the concept? Now, this is a closed loop control system, good or bad. Then a closed loop control system is good or bad, which is nothing but, for understanding I am writing like this. This closed loop control system is good or bad is nothing but a closed loop control system stability. If you want to decide it, a closed loop control system stability, now what we want to do it is, if you want to decide the closed loop control system stability, then first you want to see the closed loop control system response. The response, the output is coming only when we are applying some input. Therefore, then our aim is to find the stability of the closed loop control system. But for finding the stability, then you go to the response. The response is coming only when we are applying some input. Therefore, for finding this, then I want to start here. Therefore, now I want to see what are the different types of inputs available. We will see and choose one of the input that and see the response, and from the response then we can decide the closed loop control system stability. Now this is our concept. Now see first what are the different types of inputs, then see the response. From the response then we want to see the system stability. Now this is the concept now we are going to be identified. Once if you understand this, then you can easily identify the system gain and system time constants. Once you can easily understand the system gain and system time constants, now if the system stability and response and inputs are available to you. Take down this. Now, see here, sir, why closed loop control system? Why closed loop control system? Why you are not taking open loop control system? Then you tell me. In which case you can get an accurate output? Then you tell me. You can get an accurate output in the case of open loop control system? No, there is no error generation, there is no error analysis. The error generation, the error analysis is available in the closed loop control system. Therefore, the closed loop control system will produce the accurate output because the controller will continuously applying the controlling action as long as error becomes 0, which we already covered in the previous sessions. Therefore, the closed loop control system will give accurate output. That's why we always choose a closed loop control system. Why you choose the closed loop control system? Closed loop control system will use the accurate output, whereas in the open loop control system, the open loop control system is not at all talking about error. For choosing a best closed loop control system is always decided based on its accuracy, based on its error, right? In the open loop control system is not at all talking about the error value. Now whatever the output is coming, that should be the desired output, that should be the final output. But whatever the output is coming, not the final output, not the desired output, then this is the final output only when error equal to 0. That's why we always prefer open loop control system rather than the we always prefer a closed loop control system rather than the open loop control system. That's what I am choosing here, closed loop control system stability and closed loop control system response, and what are the different types of inputs. So now where we will start? We will start with number 1. Now what are the different types of inputs? Okay, what are the different types of theoretical or practical inputs available? First we will see. Okay, now the next topic is what are the different types of inputs? Different types of inputs different types of inputs or different types of inputs or different types of tested signals. Different types of inputs are different types of tested signals. Now, what are the different types of inputs available? What are the theoretical, what are the practical inputs available? First, if I know that, then I want to see that outputs and apply to the system and see the response, and from the response, we will decide the system stability. Now, so different types of inputs. Now, in that category, first one is case 1. Now we already know that one input, now this is practical input. This is also called as practical input, and mathematically it is called as step input. Now this is a practical input and mathematically it is called as step input. Input which we already used as input is represented by input, means reference input. Reference input is represented by R of t. in frequency domain R of S. Controlled output is represented by C of t in frequency domain C of S. This is fixed throughout our subject. Reference input and controlled output, because that is control system. Now, so this is the practical input. Now, and mathematically it is called as step input. So input we are represented by R of t. Therefore, now this is R of t, which is nothing but now for all the positive values of time, then this magnitude is constant for all the positive values of time. Now this we can represent it mathematically R of t, which is equal to A for all the positive values of time, now which is equal to 0 for the negative values of time. Now when R of t, which is equal to A for all the positive values of time, a constant, now this A is nothing but magnitude, amplitude, magnitude or amplitude. Now this is the practical input. Why this is called as practical input? Now why this is practically preferable input to test any control system, also we will see. Now this is the practical input in case 1. Now see here, if this reference input, now this reference input, the same practical input only, now here this magnitude is also constant, this magnitude is also constant, but this magnitude which is exactly equal to 1, if this magnitude is exactly equal to 1, now this reference input is called as unit step input. This reference input is called as unit step input. Now this is a reference input which is nothing but if the magnitude which is equal to 1, now which is nothing but we call as U of t, unit step input. Therefore this we can represent it mathematically in time domain R of t, which is equal to unit step input U of t, which is equal to 1 for all the positive values of time and which is equal to 0 for the negative values of time. Now this is in time domain. Now in the frequency domain what happened, now you tell me? Now in frequency domain R of S, which is equal to A into, now let us assume this is t power 0. T power 0 means what? T power n, n factorial by S power n plus 1, which is equal to 0 factorial means 1, A by S. This is Laplace transformation of step input. Then similarly, what is the Laplace transformation of unit step input? Same. Now this is nothing but R of S, which is equal to Laplace transformation of R of t, which is equal to Laplace transformation of U of t, which is equal to, now this is also 1 in t power 0, 1 means t power 0 we can write. Now t power 0 means 0 factorial by S power 0 plus 1, 0 factorial means 1, 1 by S. Now this is a case 1, a practical input which is nothing but step input or a unit step input. Now this is a practical preferable input. This is practically preferable input to test any control system. This is the practically preferable input to test any control system. This is the practically preferable input to test any control system. Why this is practically preferable input to test any control system? The reason here is, then if you observe the reference level, this is the reference level. The reference level is maintained constant. Whenever the reference level is maintained, constant. See here, whenever the reference level is maintained constant, and this is my response. Now my response is close to move the reference level such that I can easily find the error analysis. See here, now this is the reference level. Now for the best example, I am saying one simple example. Now you write the examination and the results are came, and you can get 10 marks. Out of 100, then you can get 10 marks. Means, what is your results? Your result is pass or fail or first class or distinction or what? So how you compare? So once you can get the result, then once you can get your output is 10 marks. So that 10 marks is compared with a reference level. What is the reference level? The reference level for pass percentage is 40 marks, let us assume. So the pass percentage for the reference level is 40 marks, then you can get 10 marks. That 10 marks is compared with the 40 marks. This is the 40 marks and this is the 10 marks. Then how much is the deviation? There is a large deviation of 30 marks is nothing but the error, This deviation is nothing but error. Then what we are doing? Then you work hard and go to the next exam. Then you, in the same manner here is also, then the system behavior is changing by changing the system parameter. What are the system parameters? The system parameters is nothing but gain and time constant. Change the system gain and change the system time constant, and the behavior is changing. After changing the behavior, then that behavior is good or not, you compare with the reference level. Therefore, the reference level should be always maintained constant such that you can easily estimate the error value. You can easily calculate the error value. Once if you know the error, then you obviously then estimate your performance. That's previous also I am saying the example. Then I can get 10 marks. Reference level is 40 marks. Therefore, there is a large deviation of 30 marks. Then go to the next examination. Then you work hard. Then you can get 30 marks. Then 30 marks and the reference level is how much? It is always 40%. Then 30 marks and reference level is 40 marks. How much is the deviation? Only 10 marks. Previously 30 marks. Previously error is 30 more. Now the error is only 10. Then your performance is improved or not? Like that, how much error you are expecting? Now how much error you are expecting? You are expecting the error should be more or you are expecting error should be less? We always prefer an accurate output. The accurate output is output where error should be very, very small. That's what we choose a closed loop control system. Now where the error is very less, because there is a chance of getting accurate output. That's why for getting an accurate output, the reference level should be maintained constant. That's what now the one of the input which is having always the reference level is maintained constant. That input is nothing but unit step input or step input. That's why this is called as practical inputs, and this is practically preferable input to test any control system. The control system is good or not practically is looking by its response. The response is coming after applying its input. That's what that input is nothing but the step input or unit step input. That's what here I am writing different types of tested signals. What is the meaning of tested signal? We want to test that control system by looking its response. That response is coming after applying some input. That's what the name is, different types of tested signal. And this is one of the best input to test any control system. That is nothing but step input or unit step input. This is the practically existing and preferable input to test any control system practically. Now there are some other different types of theoretical inputs also available. Theoretical inputs are also available, not for practical analysis, only for theoretical calculations. That theoretical inputs also we will see. Before that, you just take the practical inputs. Okay, this is one of the input which is nothing but the practical input. Okay, now this is in time domain and this is in frequency domain, because in frequency domain you know that our mathematical analysis is easy in frequency domain. That's why I will take the frequency domain. Now slowly we converted from this time domain to frequency domain. Now these are the practical inputs. There is some other theoretical inputs are also available. Now we will see those theoretical inputs. Now this is case 2. Now we will see theoretical inputs. Theoretical inputs, or we also called as theoretical inputs, or this is called as unbounded inputs. Unbounded inputs. These are the theoretical inputs or unbounded inputs. Now we will see this is not used for practical purpose, only for this is not used for practical purpose, only for a mathematical or theoretical calculations which we are used. This is theoretical inputs, or which we also called as unbounded inputs. Theoretical inputs are unbounded inputs. Now in that category, in the category of theoretical or unbounded inputs, in the category of theoretical or unbounded inputs, now we will see in that first one is linearly varying input. Linearly varying input. Linearly varying input, or mathematically it is called as linearly varying input or velocity input. Velocity input. Linearly varying input or velocity input, or mathematically it is called as ramp input. Now this is the linearly varying input, or now this is one of the reference input which is linearly varying input or velocity input or ramp input. Now this linearly varying input, now you know that whenever a signal is linearly varying with respect to time, if it is linearly varying with respect to time, then it is having some slope, because it is linearly changing with respect to time, it is having some slope. Therefore this is linearly varying, where A is the slope of the signal and with respect to time. Therefore here this A is nothing but slope of ramp signal. Therefore now this is R of t, which is equal to A into t. This is R of t, which is equal to A into t for t greater than 0, which is equal to 0 when t less than 0. This is linearly varying with respect to time. Therefore when a linear varying signal is having some slope, then this is slope of the ramp signal. Now this is a linearly varying input. This is the linearly varying input. Now this linearly varying input, now if this slope is exactly equal to 1, if this slope which is exactly equal to 1, then this is called as unit ramp input. Unit ramp input. Now see here, now this is a unit ramp input. Now the same thing, this is a linearly varying input, velocity input or ramp input, but where A is the slope of the ramp signal. Now if that A which is exactly equal to 1, if that A which is exactly equal to 1, then this is called as unit. Unit means whether it is a magnitude or slope or constant or whatever it may be, which is equal to exactly 1. Then this is unit ramp input, and mathematically it is represented in time domain as R of t, which is equal to 1 into t for t greater than or equal to 0, which is equal to 0 when t is less than 0. Now this is in time domain. Then what is in frequency domain? Then you know that in frequency domain, now R of s, which is equal to a into, this is t power 1 factorial by s power 1 plus 1, which is equal to a by s square. Now this is R of s, which is equal to t power 1, which is equal to 1 factorial by s power 1 plus 1, which is equal to 1 by s square. Now this is in time domain, now this is in frequency domain, now this is in time domain, this is in frequency domain. Therefore this is a linearly varying input or velocity input, ramp input, and what I am saying here is this is theoretical input, or I am also saying unbounded input. But these inputs which are not preferred practically, now this is not the practical preferable input, this is theoretical input, and this is also called as unbounded input because this is linearly varying with respect to time and it is moving towards the infinity side. That's why now this is moving towards the infinity side. That's why this is called as unbounded input. That's why this is moving towards the infinity, this is moving towards the infinity. That's why this is called as an unbounded input, which is not preferred practically, only for theoretical or mathematical calculations, and this input is used. Take this one. Now in the theoretical inputs or unbounded inputs, now we will see the second category. All these are theoretical inputs or unbounded inputs. Therefore this is the theoretical inputs or unbounded inputs. Therefore in that, now this is accelerated input. Accelerated input, or mathematically it is called as parabolic input. This is accelerated input or parabolic input. This is also the unbounded input, only theoretical inputs. Now this is the parabolic input. Now you know that the parabolic equation is y into ax square, but with respect to time here, then which is equal to y into a into t square. But what I am doing here is, this is a into t square, but in frequency domain, a into t square means 2 factorial by s power 2 plus 1. Therefore a into 2 factorial by s cube. This is actually what happened in frequency domain, right? Therefore what I am doing here is, for cancellation of this particular 2, for cancellation of this particular 2 value, then here I am taking as a by 2, here I am taking as a by 2. That's why this is a by 2, and this 2 and this 2 is cancelled. Therefore, now see here, that's why instead of this at square, now here instead of this ax square at square, because this is with respect to time, at square, then what I am taking here is a by 2 into t square. Therefore, this is a by 2 into t square. This is a by 2 into t square. Now this is r of t, which is equal to a by 2 into t square. Now which is equal to, for all the positive values of time, now which is equal to 0 for the negative values of time. Therefore, what is r of s? Now this is r of s, which is equal to, now a by 2 into t square. T square means 2 factorial by s power 2 plus 1. 2 cancel, which is equal to a by s cube. Now this is 2 cancel, then this is a by s cube. In order to cancellation of this 2, then I just take the here as a by 2. Now this is accelerated input or parabolic input. Then if this accelerated input or parabolic input, if this accelerated input or parabolic input, then if you take this a, if you take this constant of a value as 1, you know that if this is a constant or slope or magnitude, whatever may be 1, then this is nothing but unit, this is unit parabolic input. Therefore, now this is r of t, then this r of t, which is equal to time domain, now in frequency domain, r of s, which is equal to 1 by 2 into 2 factorial by s power 2 plus 1, which is equal to 1 by s cube. Therefore, these are the theoretical inputs, or which we also call as unbounded input. This is unbounded input. Why this is called as unbounded input? This is also the unbounded input because it is also moving towards infinity. This is also moving towards, now this is the unbounded input. This is also moving towards the infinity side. Now this is an unbounded input because now this is also moving towards the infinity side, which we are not used practically, only for theoretical or mathematical calculations. This is one of the unbounded input or one of the theoretical input which we are not using practically. Take this one.